along for 100 years. Sing of the Studebakers. Wagons and buggies and automobiles. Sing of the Studebakers. Born in the year 1852. Dream of a dream and it all came true. Smart as a whip or any old trip. Sing of the Studebakers. Over America's hills and plains, wheels for a mighty nation. Thundering hooves and wagon trains, clearing up transportation. Moving along for 100 years, crying out the grand old maker.
This is a factory photograph of Studebaker's main manufacturing facility in South Bend, Indiana, as it appeared in 1952. It covered over 125 acres. The oldest buildings on the site were built to manufacture horse-drawn vehicles. The site eventually evolved into the manufacturing facility where most Studebaker cars and trucks were built. Assembly operations ended in December of 1963, but much of the plant continued to operate well into 1964, producing spare parts and production components for the Canadian assembly operation. During the first portion of this film, we will see how the buildings look today, almost 25 years after production ended. We will discuss the year of construction, size, original use, and how each building was being used when production ended. Later, we will examine other Studebaker-related sites around the South Bend area. First, however, we will see an excerpt from the 1953 Studebaker dealer promotional film, Beyond a Promise, taking us on a tour of the Studebaker manufacturing operations.
Well, that day I really learned something, because we started right at the beginning, and at Studebaker, that means the foundry. The glow of the white-hot furnaces and the showering of sparks accompanies the processing of the basic raw material that goes into the making of an automobile. It's a vivid picture of America's great automobile industry with its sleeves rolled up. After being alloyed and purified, the molten metal is filled into giant containers called bull ladles and taken by overhead rail cars to the pouring floors. Here it is carefully poured into flasks containing intricate sand molds and cores to produce the castings from which some of the thousands of parts used in a modern automobile are made. When the metal is cooled, molds and cores are broken away, and the castings go into automatic shaking devices. Then they are chipped, ground, and sandblasted. Every trace of excess metal and molding sand is carefully removed by experienced workmen. Finally, after complete inspection and thorough testing, the castings are ready for the machine shop. The rough cylinder castings are loaded into a continuous line of automatic transfer machines. 900 feet away, they come out completely and accurately machined, ready for assembly. Talk about American skill and ingenuity. Here's an engineer's dream come true. Fantastically intricate machines, some costing $250,000. Automatically turn, position, bore, drill, ream, and clean the castings. Then they are quickly transferred to the next operation. Sometimes it's hard to believe your eyes. One machine 325 feet long, the only one of its kind in the industry, automatically performs 48 completely different and highly complex operations, maintaining tolerances of 1/2 of 1/1000th of an inch. Two cylinder heads are fed through and machined simultaneously by electrical control. All along the line, skilled operators keep watchful eyes on the automatic control panels, which guide the progress of the block through the intricate machine. In other parts of the machine shop, a series of sub-assembly lines are at work grinding crankshafts, connecting rods, pistons, and other engine components. At every step of the way, there is absolute insistence on extreme accuracy, and every machine part is subjected to a series of rigorous tests and inspections. Before a crankshaft can pass inspection, it must balance out to 1/8 ounce per inch, less than the weight of a thin dime. The finished parts are placed on overhead conveyors and fed to the engine assembly department. The blocks are put on traveling stands for initial assembly. They are turned on end for installation of connecting rods, pistons, camshafts, valves, and other internal parts. Finally, the engines are turned right side up as starters, carburetors, automatic chokes, and hundreds of other essential parts are added. The finished engines are placed on testing devices and under their own power, started and run for final adjustments. Meanwhile, in a separate group of buildings, work is in progress on the Studebaker body. Giant 750-ton hydraulic presses stamp steel sheets into fenders, hoods, and gas tanks. They automatically trim each section of what is later to become an automobile into the exact size called for in the specifications. The individual body stampings begin to look more like passenger cars when they are assembled in an intricate series of special jigs and fixtures, which hold them firmly in place while they're being welded together. The process of spot welding has come to play an important part in the making of today's automobiles. When the spot welding is completed, the new body is welded still more. All points of stress are given extra reinforcement by acetylene and electric welding. The skeleton body is placed on the metal finishing line to be sanded, cleaned, and made ready for painting. In the next step, the bodies are sent to the paint rooms, where heavy enamels are applied by expert workmen. After slowly passing through infrared drying ovens, they continue their journey down the production line. Gradually, roofing, upholstery, carpeting, weather stripping, and windshields are installed. Instrument panels are put into place. Then the door panels are added. Finally, all the familiar trim appointments of the Studebaker interior are installed, and the finished bodies are sent to the final assembly line. American know-how, which introduced and perfected the modern assembly line, now puts on a spectacular display as dozens of separate conveyor lines bring together the component parts, each in its proper sequence. A specific engine with the proper transmission is delivered to the line and installed on a particular chassis. Right on schedule, the specified body of the right style and color is carefully lowered into position where it meets the chassis and engine for which it was planned. Radiators, fenders, grills, all move into their proper place like clockwork. Gasoline and water are added, until at the end of the line, a gleaming new automobile is started up and driven away under its own power. One every 45 seconds. That's doing things in a big way.
The South Bend facility is actually two plants. Plant 1 is bordered by Sample Street, Prairie Avenue, Main Street, and the New York Central tracks. The first building on this site stood where Building 113 stands today. It was built about 1870 when they outgrew their original site in downtown South Bend at the corner of Michigan and Jefferson Streets. Plant 2 is everything south of Sample Street and was originally built for the production of the Light 6. The buildings were consecutively numbered as they were built except for additions, such as 47 and 47A. Therefore, the oldest buildings on the site are buildings 30 and 30A. They are located on Lafayette Street between the New York Central tracks and Sample Street. These are buildings 30 and 30A. Building 30, built in 1878, is a one-story brick building with 1,450 square feet of floor space. Just right of 30 is Building 30A. In addition, built in 1890, it is also a one-story brick building covering 1,277 square feet. The original use of these buildings is unknown. They were used for many years to house the plant protection and fire departments. This is building number 35, and attached to its east side is building number 34, and to its east side is building number 33. They are located just west of Lafayette Street, south of Building 30 and 30A. These buildings stand together and were built in 1890. Each is a 4-story, brick-walled, wood-frame structure. Together, they total about 236,000 square feet of floor space. These buildings were originally part of the wagon manufacturing complex and were at one time used for foreign shipping and car storage. They were being used to manufacture miscellaneous subassemblies for the body plant when production ended. Until October of 1987, they were the home of the Avanti Motor Corporation. On the east side of Lafayette Street, across from 30 and 30A, you find buildings 47A, Building 47, Building 48, and Building 48A. '47 and 48 were built in 1893 and 1897. They are 4 stories tall and are brick-walled with wood frame construction. 47 contains 80,000 square feet of floor space. 48 contains 84,000 square feet of floor space. These 2 buildings were originally used to manufacture saddle and harness. In 1922, additions 47A, 106,000 square feet of floor space, and 47A, 257,000 square feet of floor space were added. These are concrete, reinforced concrete, and brick buildings. This complex has been used for many purposes over the years and were the home of the truck, convertible, and Avanti final assembly operations when production ended. These buildings, located at 405 West Sample Street, are Building 53 and to the left, Building 58. 53, a 5-story brick-walled, wood-framed building with 133,000 square feet of floor space, was built in 1905. Number 58, also a 5-story brick-walled, wood-framed building containing 131,000 square feet of floor space, was built in 1906. These structures were also part of the wagon manufacturing facility. One source lists these buildings as the manufacturing site of early Studebaker gas and electric-powered automobiles. These buildings housed the salvage departments when production ended. Today, they are the home of the Newman and Altman Studebaker Parts Division. Building 62, built in 1908, was the main administration building. Standing at the corner of Main and Bronson Streets, it is a 4-story brick and steel frame building with 149,000 square feet of floor space. The 4th floor housed the executive offices, the 3rd floor the accounting department. The 2nd floor held the sales department, and the 1st floor held the lobby and the car ordering department. Today, it is the home of the South Bend School Administration offices. Building 69, found in the center of Plant 1, was built in 1913 with an addition in 1923. It is built of reinforced concrete and brick, and its 4 stories contain 162,000 square feet of floor space. It was originally used as a dry kiln for curing lumber. When production ended, floors 1 and 2 housed the body plant engineering and maintenance departments. Floors 3 and 4 were used for storage. This is building number 72, the first building built in the Plant 2 area. It stands on the southeast corner of Sample and Chapin Streets. It is a one-story brick and steel frame building covering 391,000 square feet. It held the motor, machine, and assembly operations. During the early 1950s, they were producing 1,500 engines a day in this facility. The building was built in 1917 with additions in 1918, 1928. Building number 78, a four-story reinforced concrete and steel framed building with 368,000 square feet of floor space, stands at the Franklin and Garst Street entrance to Plant 2. It was built in 1919 with additions in 1922 and 1926. The first floor housed the press room die shop and a storage area. The second floor contained the frame assembly line and the plant engineering offices. The third floor housed the tool room, and the fourth floor housed the specialty parts manufacturing department and was also used for storage. This complex is a series of 4 buildings. This 2-block-long structure stands on Franklin Street between Broadway and Garst Streets at the southeast corner of Plant 2. Building 83 is the 1-story structure in front. Building 82 is the 4-story building directly behind 83. Then another 4-story building, number 79, is attached to 83. Behind 79 stands Building 80, a 1-story structure that is hidden from view. Building 83 was built in 1919 with an addition in 1923 and is of brick and steel frame construction. It covered 70,000 square feet and was used as the rail boxcar shipping depot for finished cars. Cars were loaded 5 to a boxcar on this dock. This building remained largely unused during the Lark era as cars were shipped in open-sided rail cars or by truck and trailer. Building 82, built of reinforced concrete in 1919 with an addition in 1923, is a 4-story structure that received the cars after final assembly. The first floor housed the dollop line, where factory-installed accessories such as climatizers and radios were installed. The second floor held stock for the final line. The third floor was used for material storage. The fourth floor housed the color enamel department, where hoods and front-end sheet metal assemblies were painted. Building 82, directly behind this, contained 316,000 square feet of floor space. Behind Building 82 is Building 79, the largest building in this group with 508,000 square feet of floor space. Built in 1919 with an addition in 1922 and 1926, this steel-framed reinforced concrete structure was a beehive of activity. The east side, on the first floor, was the finished car repair shop. The second floor was the final assembly line. The third floor received bodies from the north side of Plant 1 for final assembly and housed the gas tank assembly area. The fourth floor housed the wheel, storage, and tire mounting departments. The west side of 79 on the first floor housed the small press room. The second floor was used for front fender fabrication. The third floor housed the hood fabrication division and the front end assembly departments. And the fourth floor was devoted to the black enamel department for the front end assemblies. Behind all of this was Building 80, a 113,000 square foot, 1-story brick and steel frame building built in 1919